Hello everybody, my name is Bethanie Williams,
And Marena Soulet.
and today we'll be presenting our paper which is called A Taxonomy of Cyber Attacks in Smart Manufacturing Systems. So Marena and I have done research on cyber attacks that have taken place in the manufacturing sector over the last several years. We also looked into the Cybersecurity Framework for Manufacturing, which was created by the National Institute of Standards of Technology, also known as NIST. Through our research, we discovered that all cyber attacks reported have not ever been connected to NIST. Thus, we decided to write a survey paper that makes a connection between NIST framework and as many cyber incidents as possible. In this survey, we had 4 main objectives. Explore the most common security challenges and attacks faced by the manufacturing sector. Also, apply the NIST manufacturing framework as a roadmap to reducing cybersecurity risk. We also wanted to raise awareness to manufacturers and researchers about security issues in the smart manufacturing industry. We hope that this paper will help others gain a better understanding of how to secure manufacturing systems through the creation of our proposed taxonomy.
For just a quick recap on how this term is actually defined, according to NIST, the National Institute of Standards and Technology, it is any fully integrated, collaborative manufacturing system that responds in real time to meet changing demands and conditions in the factory, in the supply network, and in customer needs. So, in simple terms, these systems use a technology-driven approach that use internet-connected machinery to improve the production process. It is being called the next industrial revolution, hence why you might hear it also being referred to as Industry 4.0. And thanks to the Internet of Things, never before have we had this much access to and contextualization of the data these systems analyze. Think of your smartphone only on a grander scale.
More people are moving towards smart manufacturing because of the competitive advantages it has to offer. Now, because of this, cyber attacks are increasing in frequency and sophistication within the manufacturing sector. These cyber attacks pose a significant threat to companies and organizations worldwide, and can cause damages to physical systems, delay production, or even create risk for human safety. Manufacturing was one of the top 5 most targeted industries in 2016, 2017, and 2018. Despite the manufacturing sector being one of the most targeted industries in the world, many manufacturers are not taking the appropriate security measures to be well prepared against cyber threats and cyber attacks. As a result, cyber attacks have caused the loss of over 40,000 manufacturing jobs in the U.S. alone. It has also caused the U.S. to lose as much as $70 billion in gross domestic product, which is a huge loss for our economy.
Due to cyber attacks posing such high risks, there needs to be a national standard that these companies look up to in order to secure these systems, whether it be processes or equipment, and ensure that they are optimized to enable cost-effective and agile manufacturing of these high-tech products and systems. This is where NIST comes in, as it is one of the nation's oldest physical science laboratories that promote U.S. innovation and industrial competitiveness. They are pretty much responsible for supporting and developing information security standards and guidelines for many industries, including, you guessed it, the manufacturing sector.
In what ways has NIST been involved in the manufacturing sector, you might ask? Well, NIST has created a cybersecurity framework for manufacturing, which helps manufacturers become more aware of potential security challenges, reduce cybersecurity risk, identify when an attack may be occurring, and learn how to recover from cyber attacks. This framework will provide manufacturing systems of all sizes, from big corporations to small-owned businesses, to have the same fundamental structure of security protocol and procedures, which will ensure protection against cyber attacks. It is aimed at reducing and better managing cybersecurity risk. The figure on the right shows the cybersecurity framework's 5 functions, which include identifying, protect, detect, respond, and recover.
In the development of this framework, or as they call it, the manufacturing profile, they included the identification of common business or mission objectives relevant to the manufacturing sector. These objectives provide the necessary context for identifying and managing cybersecurity risk mitigation pursuits. Key cybersecurity practices are later identified for supporting each business objective, which allows users to better prioritize actions and resources according to the user's defined needs. So let's go over them real quick. The first one is maintain human safety, which is being able to manage risks that could potentially impact human safety. The second one is managing risk that could adversely affect the environment, whether it be accidental or deliberate damage or both. The next one is being able to manage risks that can impact the quality of product, such as being able to protect against compromise of integrity of the manufacturing process and its associated data. The next to last one are risks that can impact production goals. Cybersecurity risk on the manufacturing system, including asset damage, could potentially adversely affect production goals. And the last one is managing risks that could lead to the loss or compromise of the organization's intellectual property and sensitive business data. In many of these cases, personnel should understand the interdependencies that exist between cybersecurity and these objectives.
NIST categorization process was developed to categorize cyber attacks based on their potential risk or impacts. There are 3 types of security levels: low, moderate, and high. Since these security levels allow attacks to be categorized by the significance of the threat they may cause to the manufacturer, this also allows manufacturers to prioritize specific needs for their organization. I'm sure you have heard of the CIA triad before, right? Well, NIST uses the CIA triad to analyze what type of impact a threat may potentially cause for the manufacturer. This means that confidentiality, integrity, and availability will play key roles in determining what security level a threat or attack may get categorized as. So, for example, the potential impact is low if the CIA triad is expected to have a limited adverse effect on manufacturing or operations, moderate if it's expected to have a serious effect, or high if it's expected to have a severe or catastrophic effect. This categorization process will be influential in helping manufacturers and other organizations decide what security measures need to be implemented to ensure proper protection.
In our paper, we shared our own perspective and thoughts of how NIST framework can be seen solely through the lens of cyber attacks. Through their manufacturing profile, it is believed that cyber attacks can be mapped to both the manufacturing objectives and the categorization process based on security levels. Why are taxonomies important, you might ask? Well, it's always important to review and analyze cybersecurity issues within any sector in order to properly address them. By mapping cyber attacks with the manufacturing objectives, one can see how cyber attacks can affect the different missions of manufacturing systems, therefore allowing both researchers and manufacturers to see how to identify which objective is being targeted. This will give a clearer categorization of cyber attacks based upon their framework, and thus would enable one to develop preventative or responsive approaches based upon the attacks mentioned in the proposed taxonomy.
This is a diagram we created to represent the structure of what our taxonomy looks like. As you can tell, the first layer of our taxonomy consists of 5 categories, which are NIST manufacturing objectives, including human safety, environmental safety, quality of product, production goals, and trade secrets. Now, we know that some cyber attacks could affect multiple of these categories, or the attacks could simply affect only one of the objectives. However, in our taxonomy, we decided to categorize the attacks in one objective or another. We also have other layers of the taxonomy, which will be described on the next slide. So these are the attributes that we added to the taxonomy. They include the incident itself, the attack mechanism that the attackers use to attack the system, the level of impact, which we discussed can be either high, low, or moderate. We also included actors, so those who attacked the system or tried to cause harm to the system. We included the CIA violation, so did the attack affect confidentiality, integrity, or availability. We also put the type of threat, which can include deception, disclosure, disruption, or usurpation.
So let's start with the first dimension. The first category we talked about was human safety. You have incidents such as the Jeep Cherokee ignition switch hack that happened in 2015, where it was announced that hackers had taken control of a Jeep Cherokee through its internet accessible entertainment system. The vulnerability impacted over 1 million vehicles purchased in the US, which had been equipped with the company's Bluetooth system. And the hackers were able to do that by using a technique classified as a zero-day exploit, which allowed them to execute code that allowed them to wirelessly break into the vehicle system and grant them access to control vital functions such as steering, brakes, and transmission. You also hear about the one that occurred in 2017 when it was announced that an oil and gas petrochemical center in Saudi Arabia had experienced an emergency shutdown as a result of a malware attack. The malware, termed Triton, also known as Trices or Hatman, exceeded other industrial cyber attacks by targeting safety instrumented systems into running unauthorized programs on the safety instrumented system. The incident resulted in millions of dollars in lost production and posed as a threat to human life, as dozens of people could have been killed.
In this part of the taxonomy, our main concern is what effects cyber attacks might impose on the environment. I'll start with a low-impact attack that occurred in 2013 on a New York dam. In this attack, a small group of Iranians were able to access information about the dam's operations, like the water level, the temperature, etc. However, they were not able to cause any physical damages to any aspect of the dam. Imagine if this attack occurred on a big dam like the Hoover Dam. This could have caused large-scale flooding in urban and rural areas throughout Nevada. Another moderate impact is related to a U.S. turbine control system. In 2012, a computer virus was on an employee's USB drive and infected the computers on the system's network. The malware attempted to steal classified information but resulted in serious economic loss due to the plant being shut down for 3 weeks. This cyber attack can be classified as a moderate impact incident due to the plant's activeness in recovering from the incident because it did not restrict the plant from producing electricity.
The third part of the taxonomy had to do with security events that dealt with the quality of product being tampered. You have one that happened in 2016 when malicious actors successfully penetrated a water utilities logic control system and altered the levels of chemicals being used to treat tap water to make it safe for consumption. The group was able to compromise Camry Water Company's computers after exploiting vulnerabilities in its internet-facing customer payment portal. The hack, which involved SQL injection and phishing, was made easier because login credentials for the operational control system were stored on the web server. And the last one on this list occurred in 2017, and is probably one of the most well-known attacks, and it's the WannaCry virus. It started simply as a ransomware worm, spread swiftly across a number of computer networks. The massive global attack infected more than 300,000 computers in over 150 countries around the world. And how exactly did they do that? The ransomware took advantage of a security vulnerability in Microsoft's operating system. The crypto worm, after successfully infecting a Windows computer, would encrypt files on the machine's hard drive, making them inaccessible for the user, and it would then pressure the victim into paying a ransom payment in order to decrypt them.
The next cyber attack that I'm going to discuss is probably going to relate to production goals. So the first one is probably the most famous cyber physical attacks that have ever occurred, and it is known as Stuxnet. Stuxnet is actually a computer worm that destroyed nearly 1/5 of the centrifuges at an Iranian nuclear plant. The attackers gained enough access to change the displays of the machines to cause misreading values. This attack caused a tremendous amount of physical damage to the machines. Finally, in 2019, one of the world's largest aluminum manufacturing companies was attacked through the use of ransomware, called LockerGaga. The ransomware accessed and encrypted data on all the devices it infected. By infecting 40 sites of the company worldwide, hackers were able to gain enough access to shut down both the manufacturer's production system and their network. All automated manufacturing systems were stopped and had to be manually operated. The attack caused the company to lose between $50 and $54 million and significantly reduced the production process.
And last but not least, our fifth dimension is trade secrets. Third on the list is Deloitte, one of the world's big four accounting firms. In 2017, they reported a massive cybersecurity data breach. Hackers were able to gain access to the email server, and this allowed them to obtain valuable information such as usernames, passwords, IP addresses, business information, and even workers' health record. This attack led to major security concerns about Deloitte's email systems and servers. And lastly, in 2013, Target discovered an extensive data breach. Hackers were able to gain valuable information about millions of customers. Specifically, the attack led to the theft of approximately 40 million payment card records along with 70 million other information records such as addresses and phone numbers. Having customers' information exploited in that way and exposed to people worldwide would cost Target millions of dollars.
To understand potential vulnerabilities and protect manufacturing system standards, we developed a taxonomy in which we presented today. The proposed taxonomy lists a variety of cyber attacks that have occurred throughout cyber history, but also uses the NIST framework Cybersecurity Manufacturing Profile to categorize attacks, with our addition of proposed taxonomy attributes, including the attack mechanism, CIA violation, and the attackers who performed the attack. We hope that using this framework, researchers and organizations can categorize cyber attacks in a more accessible manner to create awareness about the damages caused by the attacks.
Future research opportunities in this area could include incorporating mitigation techniques for these type of cyber attacks with the NIST standards and framework, and improving vulnerability and risk assessments. Most of these attacks mentioned in the taxonomy could have been prevented if better security protocols were in place. The taxonomy will provide the manufacturing industry with a deeper understanding of how to better secure smart manufacturing systems. Thank you for your time.